I've had a couple of people ask if I could do a video that would show how you would take a hydrogen alpha image and fold that into an RGB or an LRGB image. And I thought I could probably do that with a project I did about a year ago on Messier 57, the Ring Nebula. This is about 14.7 hours of integration with LRGB and hydrogen alpha. And what I've done here on the image on the left, I've done most of the processing, bringing us up to an LRGB. It's not done yet. There's more than I would normally do to this, but it gives you an idea of the structure I was able to get using the broadband data. And you can see just a hint of something else going on the outside. There's a hint of gas shells on the outside. However, with the hydrogen alpha channel, I've got quite a bit of detail and quite a bit of structure that's come through that. And what I'd like to do is take this data and fold it into this image. Now, hydrogen alpha is primarily in the red spectrum. So what I'd like to do is add this detail into the red layer. And one way that's very common to do that is using PixelMath. And in PixelMath, I have an equation here where I'm basically saying I'm going to take the 0th layer of the target image, and in this case that's the red layer. I'm going to multiply it times a weight. Then I'm going to take the hydrogen alpha image that I want to use by name, and I'm going to multiply that by another weight, and then I'm going to add the two together. And the idea here is you want these two weights to add up to 1. And so you're basically talking about what contribution you want each image in the final image to have. Now, this PixelMath also has a green definition, which basically says take the first layer, which is the green layer, and just copy it over untouched. And the blue is doing the same thing with the next layer. So all the action's really going on the red layer here, and we're ready to go. If I drag this onto this image, we'll do this particular combination. And this is the weighting I'd done with my original imaging project, so I'm leaving it there. Most images, like I said, you're going to probably want to test different weights out and see what looks better. So let's try doing this. Well, that's a different result. First thing we notice is we brought in a lot of structure from the image, and that came in and looked good. The second thing we're going to see is that the entire balance has shifted a little bit. Well, why is that? Well, there's actually some signal all around here, right, from the hydrogen alpha. Even the background has a signal. And if I add that back in, it's going to make this a stronger signal, and it shifts the balance. Now, I could fix this by going in and doing color correction to bring it back to where I want it. But I'd like to show you another way you could do that, which is a little bit more sophisticated. Let's bring this back to where we were before. Now, if you recall, I have another video that talks about how you can take a range mask, edit it to turn it into an object mask. And I've done that here. I created a range mask of the hydrogen alpha. Then I edited it to take all the stars out and all the background. So this is all black in here, but I preserved all the structural detail in the areas where there is structural detail from the hydrogen alpha image. If I take that mask and apply it to this image, and we'll click over here and just verify that it's there, you can see where it's allowing signal to come in and where it's not. Now with that in place, let's try doing this PixelMath operation again. And with that, we get a much better result. In this case, we're pasting hydrogen alpha data only where there should be hydrogen alpha data because there's structure there. We're leaving the rest of the image untouched. And this provides a pretty good effect for what we want to do. So I think this idea of using the PixelMath and a weighted equation to balance your images is a good way in general to bring in hydrogen alpha data. Sometimes you may have to do some balancing to get that right afterwards, or you may choose to constrain where that action is happening with a mask that is built from the hydrogen alpha image to begin with.